Good morning, mathematicians. Today we'll be doing lesson 8.6, Formula for the Area of a Parallelogram. Our objectives for today are to review the properties of parallelograms and to use a formula for the area of a parallelogram. Before we get started on our warm-up, I want to remind you of the area formula for rectangles that we learned about yesterday. We know that area is equal to the length of the rectangle times its width, or also known as base times its height, which means the same thing. So I would like you now to use the area formula to figure out the area of this rectangle right here. So it's got a side that's 7 inches, a side that's 3 inches, and on your board I would like to see the formula written out as well as the answer. If you said that the area equals 7, which is its length, times 3, which is its width, and then the area then equals 21 inches squared, you are correct. Let's look at one more rectangle. Now use the formula to figure out the area of this rectangle. If you said that the area equals 4 times 2, and then you got an answer of 8 square inches, you are correct. Go ahead and erase your boards and put those off to the side. Today we're going to use what we know about rectangle and area to help find the area of parallelograms. But first, let's think about what we already know about parallelograms. Go ahead and talk with your partner about all of the properties that you can name for parallelograms. Many of us said that parallelograms are four-sided polygons called quadrangles or quadrilaterals, that the opposite sides are parallel, that the opposite sides are the same length, and that rectangles and squares are special kinds of parallelograms. Just like with our rectangles, we can also label parallelograms with base and height. We can think of the base as the side that the parallelogram is sitting on. So I'm going to label this side the base, and then the height of the parallelogram is the shortest distance between the base and the side opposite the base. It must form a perpendicular line to create the height. So I'm going to start up here and draw that perpendicular line down. We know that there's a right angle, so here is our height. Remember that rectangles are simply parallelograms whose sides form right angles. So we can still think of the bottom here as our base, and the side over here as our height, because we can see that the right angle is formed right in the corner. Today we're going to use the formula for the area of a rectangle that we learned yesterday to develop a formula for the area of a parallelogram. To complete our work on page 236 in our math journal today, we are going to be using MathMasters as well, just like you see here. The directions say, cut out a parallelogram A on MathMasters page 260. Do not cut out the one below. Cut it into two pieces so that it can be made into a rectangle. So looking here is parallelogram A. I can see that if I cut right along this line right here, I can move this piece all the way over here to create the rectangle. As you can see here, I made my cut right on one of the lines from the other side, and then I taped it together to create and form my rectangle. My next step after creating the rectangle from parallelogram A is to tape my rectangle in the space below in my journal. So I would take that rectangle and tape it right in that space, and I can see and compare parallelogram A and rectangle A right here. Let's think about parallelogram A and rectangle A. I want you to turn and talk with your partner now about why they must both have the same area. Go ahead and do that now. Yes, the rectangle was made from the parallelogram, so we didn't lose or add anything. We just moved that small piece to the other side right here. So it has the same amount of squares, it just looks a little bit different. So now we want to record the length of the base of our parallelogram and our rectangle. So here I can see the base is 1, 2, 3, 4, 5, 6 centimeters long. And over here as well, 1, 2, 3, 4, 5, 6 centimeters. And remember, for our parallelogram, the height is the shortest distance between the base and the side opposite the base, which would be right here. And we can see that's 2 squares, so 2 centimeters. And looking at our rectangle, there's 2 for the height as well, 2 centimeters. I already know the formula to figure out the area of a rectangle is area equals base times height, or length times width. So I can multiply 6 times 2 to get my area of 12. And I can double check by counting as well. We know that as we cut and moved pieces from this parallelogram to create this rectangle, nothing about the area changed. It is still the same amount of squares, but it just looks a little bit different. So we can decide that the formula for a parallelogram is also similar. We can still do area equals base times height to figure out the area of the parallelogram. So that would also be 12 centimeters squared. Let's open up to the bottom of page 237 to make sure that everybody is able to write the formula for the area of the parallelogram. And as we said before, our area still equals base times height, just like it did for our rectangles. For today's work, we already completed mental math. You'll need to finish Math Journal page 236 to 238. Make sure you finished your math boxes if you haven't yet. And then you'll move on to Blend Space Practice F for Activity B and Blend Space Practice H for Activity C. Make it a great day.